Well, hello there, boys and girls. And we're going to use this thing right here, Dixon Ticonderoga number 2. Probably going to have to do a little bit of drawing, so I'm going to use a straight edge just to be nice and pretty. And we're going to deal with some bearings. A lot of you guys asked a question. Let's see if we can get this to focus a little bit. Oh, man. Almost fall break. Number 6 seemed to cause a lot of trouble. Number 4 did too. We'll discuss that one in a different video. But for number 6, it says, let's read it, right? It says, a ship's captain sees a marker buoy on a bearing of 73 degrees, 073. Remember, bearings have to have 3 digits, right? And a port on a bearing of 90 degrees. So 90 degrees would be directly to the right. That would be directly to the east. Okay? The captain knows that the marker buoy is 5 kilometers away. Also, we have a right triangle right here. Due north of the port. Oh, okay. So this marker is due north of the port. Okay. And the port is 90 degrees from where he is. We got a right triangle right there. Draw a sketch to show the information and calculate the distance in kilometers that the ship has to sail to reach port. So this is kind of a tricky thing, right? I've not done this problem before. Let's just go ahead and see if we can sketch this out. Here's what I'll do. Here's what I would suggest. Look, a lot of time you just start. You're not really sure how the whole thing's going to work out. But let's say the ship is right here. And then let's see if we can piece together the information. All right, so look, here's what I remember. It said that, let's see. It says that the marker buoy is a bearing of 73 degrees. Okay, so here's the deal. Bearings are from north and they go clockwise. So 073 degrees. I'm actually going to use my, check this out. So look, check this out. This is true north right here. So this is going to give me my reference right here. All right, now 73 degrees would be starting, let's see, make sure we can see this. Using our protractor. So I'm kind of doing 2 things right here. In class we haven't had a chance to learn how to use these yet, but here's what you got to do. You got to make sure that your dot is exactly centered. Exactly. You have to be so careful. You have to be incredibly patient. And then you have to make sure that the line you drew lines up with this line right here on the protractor. So even though it said sketch, we're going to do it accurately. So 73 degrees. So another thing that's confusing is there's 2 70s. We got a 70 here, and we also have a 70 here. But the thing is, this 70 is rotating this direction from down here. So we're going 73 degrees. So 71, 2, and 3 degrees. So 73 degrees. So on a bearing of 73 degrees, that's 73 degrees. And this is, what was here? A buoy. So that's like a thing that floats in the water that's a marker. Let me make sure I got this right. 73 degrees, yeah. So here's where our buoy is right there, and that's a 73 degree, I forgot the 0, bearing from the ship. And there's a port, it's a bearing of 90 degrees. So 90 degrees, that would be over here. Okay, so port is over here. This is not how I visualized, this is not how I had visualized it when I was reading the problem. Okay. The captain knows that the marker buoy is 5 kilometers due north. Due north. So due north, it says that watch, check this out. It says the captain knows that the marker buoy is 5 kilometers due north of the port. Okay. Now sketch all right, so 5 miles due north. So that means that this is going to be like this distance right here. It's going to be due north from here. Okay? So this is due north. So here's the thing I know. This is the port. From here to here is, remember, that's now a 90 degree thing right there. And so that's going to be a right angle because it said this is 5 kilometers due north. So here's the thing. Look, 90 degrees is due east. So from here, the ship is due east of, or the port is due east of the ship. And there's a 73 degree rotation, so bearing of 073 degrees from the ship to the buoy. So it's kind of like this. Here's kind of how bearings work. Let's say you're standing right here, and you're facing due north, okay? You're facing due north. And a 73 degree bearing would be how far, let's say this is 73 degrees. How far do you have to turn before you're facing the buoy? So you start off facing north, and how far do you have to rotate before you're facing that direction? And you turn clockwise. So from the ship, if you're looking north, and then you turn 73 degrees, you'd be facing the buoy. So you haven't moved. You're still here. But instead of looking north, you're now looking over here if you turn 73 degrees, and that's facing the buoy. If you turn 90 degrees, you'd be facing here. So it's kind of like, yeah, it's kind of like that. And then if you turned 90 degrees, now you're facing the port. So I know it took a lot of time to try to explain how that works. Oh man, all right, now, it says, the instructions say to sketch it and then calculate the distance in kilometers that the ship has to sail to reach port. So if the ship is here, and we're going to assume they take the direct distance, that means that the ship's going to go that distance right here. So how far is it from here to here? And here's what we know. If it's 90 degrees from the ship to the port, and it's 73 degrees from the ship to the buoy, then this angle right in here is going to be 90 minus 73, so it's 17 degrees. Do you see? So what we have is we have a right triangle, right? And this is a 17 degree angle, hashtag not to scale. Hold on, I'll move my paper for you, sorry about that. This is 5 kilometers. This is where the ship is, this is where port is, and this is where the buoy is. Do you see? So, and we need to find this side right here. Okay? So this is a right triangle, so we can use sine, cosine, or tangent. We need this side. That's the adjacent side. And we have the opposite side. So we know that tangent of an angle is opposite over adjacent. So the angle is 17 degrees. The opposite side is 5 kilometers. The side we don't know is the adjacent side. So we're going to have to do a little math. We're going to have to do a little bit of math right here, right? So what I'm going to do is, we could actually use, I don't remember if you guys remember this, but we could use cotangent instead. Cotangent is the reciprocal. So cotangent is the reciprocal, but since we didn't start with that, let's go ahead and do it like this. Let's say this is x, right? So then we have x tangent of 17 degrees equals 5 kilometers, right? And then we're going to divide both sides by a tangent of 17 degrees. Right? So, here's what we got. We've got that, I'll write it over here. We've got that x equals 5 kilometers, right? 5 kilometers divided by the tangent of 17 degrees. Let's see what that equals. 5 divided by tangent 17 degrees. Oop. Let's see here. 16 point, now if we're going to round this to 3 significant figures, it's going to be 16.6 kilometers. Correct. 3 significant figures. 16.6. All right, so now we got that done. Let's go ahead and take a look in the back of the book, see what we got. So that was chapter 9.9, numbers, SACE. 9.9, let's see here. Chapter 9.9, number 6. Let's use the book, see if we got it right. Notice we didn't use the book to get a clue. Even though it was confusing, we just, tackled it with good faith, tried to figure it out. Just we used one piece of information at a time. So 9.9, oh wait, 9.9, where are we at here? That's chapter 7, chapter 9, exercise. Oh, look at 16.4. It says 16.4, and I said it was 16.6. Oh my gosh. You guys are probably screaming at me. Of course it's 16.4. I don't know what I did right. I rounded. Oh my goodness gracious. Man, you need to get your glasses checked or something. I swear I saw 16.55. All right. So anyway, 16.4. Whoa. All right. I did not do that on purpose, but let me tell you guys this. When you guys take tests, in your work, show that, do it something like this, right? And then write it out 16.4. Because if you make a silly mistake like I did right there, I looked at the 5 and like, oh, I got to round it up or whatever. If you make a silly mistake, they're going to see this. You might get full credit. Because, you know, that was obviously just one of those things paying, it's a lack of attention kind of detail issue. And we all make those mistakes. So, yeah, just do that. Just be careful with it. So anyway, I hope this has been helpful. You guys are killing it.